Okay, so integrate this with respect to x. So remember the integral symbol like that, okay? With respect to x then, well, we need to put dx there at the end to show what we integrating with respect to. Okay, so this is the reverse process, isn't it, of differentiation. And just like with differentiation, right, you need to sort this out so it makes it easy for us to integrate. So, you know, that there I would write as 3x to the power half, yeah, because that's what square root means. And x cubed on the bottom, well, we need to take it up, don't we? So that will be x to the minus 3 on the top, okay? So then, when we integrate, different process to differentiation. In fact, it's the complete reverse, the complete opposite, and done in the reverse way as well. So the first thing you do is you add 1 to that power. Okay, that's the first thing you do. You've got to add 1 to that power. So you get 3 over 2. When I add 1 to that, check on your calculator if you want. And then you divide by that new power, 3 over 2. And it's as simple as that. Same here. Add 1 to that power there. So if you add 1 to minus 3, you get minus 2. Okay, so be careful, it's not minus 4. And again, as I said, use your calculator. Minus 3, add 1, comes to minus 2, right? In the exam, you're under pressure. You want to just double check that. And divide by that new power there, okay, which is minus 2. And then don't forget, you've got to put this constant of integration on as well. There's a constant there because it just sort of hits home with that idea. When you differentiate a constant, it disappears, doesn't it? When you differentiate a constant, it goes. So when you integrate, there could be a constant there, right? So make sure you put that in, otherwise you lose a mark. And then when you've got this then, well, we can flip the bottom fraction, can't we? We can take the 2 up. So it'll be 2 taken up there, so times by that 3, which would be 6, okay? And then divide by 3 would be 2, okay? So overall there you get this. Again, you can check on your calculator, 3 divided by that. Same here then, minus and minus make a plus. 6 divided by 2 is 3. And you get then your answer there, okay? So we're all done there for part A. So part B then, it asks us to, first of all, find the coordinates of A and B, okay? So you've got a curve, which is y equals 16 minus x squared, and the line y equals 2x plus 13, okay? And to get the coordinates of A and B, just take note, of course, that's where the curve and line intersect, okay? So where they intersect, we can solve simultaneously. Okay, so if I call this 1 and 2, solving, okay, simultaneously, of course the y's will be equal, won't they, at A and B? So the y's are equal, that means this expression will equal, this expression for y will equal that expression for y there, because the curve value and line value will be the same in terms of y and x. So we've got it in terms of y here, which is nice. Got y equals, so 2x plus 13 will equal the 16 minus x squared. Get it all onto one side, so we've got x squared plus 2x minus 3 equals 0. Okay. 2 brackets then. So 3 and 1 plus 3 minus 1, that will give us what we want. So therefore x minus 1 is 0, or x plus 3 is 0. So x will equal 1, or x will equal minus 3. Okay, and then we've got our x values. To get our y values, we just need to sub it in. Now, you could sub it into either one, it's your choice, it really is. So when x is 1, y will equal to 2 times 1 plus 13. I'm going to sub it into the second one, so that's 15. And when x is minus 3, y will equal to 2 times minus 3 plus 13, which will equal to, what will that be, 7, right? So my a, clearly my a will be negative, because when you go back to the graph here, yeah, that's going to be the negative x value there. Okay, so a will be minus 3, 7, and b will be 1, 15. Okay, so we identify correctly there what your a and what your b is.